Hi, I'm James McGuire, and on today's eSpeaks, we're talking about databases, in particular serverless databases. We'll find out the advantages of this database technology and take a look at its role in cloud-native environments. To discuss that, I'm joined by a major industry expert. With me is Jim Walker, Principal Product Evangelist at Cockroach Labs. Jim, happy Friday to you, and thanks for joining us today.
Hey, James, happy Friday to yourself from the other coast. I'm happy to be here. Thanks for having me.
I see you. That is Manhattan in the background, or at least New York City.
That is Midtown out there somewhere. So
that's exciting. So let's do a little bit of background about the technology itself. Serverless databases. We know what a database is. It's a collection of data. It's a big application that holds our data that helps us organize it and retrieve it when we need it. Serverless, of course, has been hot for like the last 5 years or so. The cloud companies handle that. They handle the provisioning of the software, of the hardware, so the application developer doesn't need to worry about that. But a serverless database, so what is a serverless database in terms that even I can understand?
Yeah, so it's funny. We kind of struggled with this internally as we built this out. Like, how do you define what this kind of serverless database thing is? And the easiest way for me to explain this is kind of like, look, we've always had a telephone. And remember, you had that landline where you had to the rotating the numbers, and if anybody had zeros in their number, you hated them. I guess I'm aging myself, right? Well, eventually we got to wireless, and then we got to our cell phones we've applied wireless to the concept of the phone, right? Look at cars, right? A car is still a car. We have electric cars. Well, we've taken electricity or the electric concepts and applied it to a car. What we're doing here is we're just taking these concepts around serverless, this paradigm of serverless computing, and we're applying it to a database. Now, I think the database is a really interesting part of the infrastructure to apply these principles to. And I'll talk about the principles in a second, but I think we're going to apply these serverless principles to lots of different things that we have, I think, eventually. Because ultimately the promise of serverless is, to allow people to consume only what they want to consume. To eliminate the need for any kind of backend operations of our backend systems, to kind of obviate and exclude out all the things that are complexities that I don't need to be an infrastructure engineer. I just want to do my thing. And so how do we abstract all those things away and create this kind of clean layer between developers and people who want to do things and builders and the stuff that's underneath? We're doing that for the database.
But here's my question, I think, about the idea of serverless databases. I know we need serverless for these dynamic applications that are being written on the fly. They're fast, maybe it's microservices. But I think about a database as something that sits there. It's basically pretty much whole. So you provision it, and then it's fairly well provisioned. It doesn't need the dynamic provisioning that something else might. But correct me when I'm wrong.
Well, it seems like that, and it might be great. And the database, you provision it once, it works. It's one of these things. What happens when your business is successful and the database has to scale? And when I think about scale, I just don't think about the amount of data. I think about the number of transactions that are interacting with that database. Can I handle the volume of the users that are growing? Even worse, and this is one of those things I think the ubiquity of the cloud delivers for us, but I think we haven't really thought about this in our applications, or the developer doesn't think about this. What about geographic scale, James? Like, what happens when I have users all over the planet? Because the latency between New York and Singapore, well, that's going to take a whole long time to go back and forth a couple times, right? And so we're starting to deal with the physical limitations of our world when we start to do these sort of things. And the speed of light is no joke. And so, scale becomes a really big issue. If you have one instance of a database that's sitting in, say, some data center in Oregon somewhere, and everybody's accessing it from across the world, well, it's going to fall over eventually. And honestly, the time it takes for people to get there, it causes issues. And people are impatient. We're all more and more impatient with our systems and everything today. So I think that's one of those big challenges.
So that in a sense is what's driving the market adoption of serverless databases. Things need to scale at any number of levels, including geographically. So people want the serverless database because of its scalability.
Well, kind of, and I think the cloud is really driving these. I think the cloud in general is driving this push towards scale, and I think it promises this scale, ubiquity, and these things. It promises efficiencies as well. I don't want to deal with the management of all this backend stuff and infrastructure to make this happen. And for us, if we can apply the concepts of serverless, where it can kind of elastically scale up and down. It can be deployed across the whole planet. I don't even have to think about the management and operations. It can be always on and resilient. Like, how do you do that with a database? You know, in the old world, we have these active passive databases. Well, in a distributed system and something that's truly a serverless database, how do you have like instances of it where it's one single logical database everywhere, and it's going to be, you know, it's going to be resilient to failure, you know, and ultimately, I think what's really interesting about serverless for end customers, really in the advent of, you know, the everything kind of becoming a service, is I don't want to pay for what I'm not using, you know, and so how do we make these things consumption based? And that's where databases are really changing today. And I think that's where the serverless stuff gets really interesting for organizations.
Wasn't there a moment when AWS really introduced serverless in a big way, that it actually lowered the cost and it forced some of the other cloud developers to say, cloud providers to say, we need to be doing serverless as well? I mean, didn't serverless actually make things cheaper?
It can, it definitely can help to do that, because again, we're getting back to like, I only want to pay for what I consume. You know, instead of setting up a database and having it run on some instance of a server in the cloud somewhere, I don't have to pay for that full instance of that server. I only have to pay for the pieces of the compute cycles that I use. And that from a consumption point of view, I think is extremely powerful. When I start really thinking about serverless and what it's going to deliver for, you know, say a single organization, what if I had, you know, if I'm, you know, Acme Insurance or something, and I have a serverless database, and I can have it to be multi-tenant, where I have, you know, multiple different users all using that, I can really start to drive down the cost of goods sold, or, you know, the cost of compute, because I can now consolidate that into one thing. And then each person is, you know, each application is picking off their little cycles. And so it's really about, you know, how do we optimize and create efficiencies around spend within the cloud. And I think that's going to be this is, to me, this is the next frontier of how we start to really think about our applications, is how do we start to, you know, drive spend overall for these things. So we do it today, and you know, and we have to, because we offer a service, so we have to actually shrink our own cost of goods sold as well. And so we do it for ourselves.
So how will serverless databases change the way that developers work with databases? I'm assuming it streamlines it quite a bit.
Yeah, you know, for, you know, my vision is, look at, you know, I was a developer. There are certain things I didn't like to do as a developer, James, like, you know, like unit testing and code and commenting and these sort of things. The last thing I wanted to do was like go manage the database. But, you know, as developers, we're kind of left to do that sometimes, because we're just building, and, you know, you kind of start building, and typically developers just choose whatever they're familiar with. They don't understand that, like, oh, wait, what happens when I'm successful, or how is this going to integrate with other things in the back ends? And, you know, and so for us, you know, I imagine a world where the database really gets abstracted to an API that's in the cloud somewhere. You know, the same way that a developer is going to code against, you know, some tooling framework at Twilio or something like that, like where they're integrating tools within their apps. I really do believe the database can be a, you know, a connection string in the sky, is what one of my friends call it. I like to think about it as a SQL API in the cloud, where 7 endpoints around the planet, I'm asking for data, I have get and puts, I'm doing selects and joins and all these really great SQL things against the database. And it just works. And I don't have to worry about upgrading it. I don't have to worry about scaling it. I don't have to worry about it being on or resilient. You know, the service provider of that global kind of Skynet service, it's like, you know, they're doing that for me. And I think the database really could just be a service for people.
It definitely seems like serverless and that idea of an API in the cloud is very much the true promise of the cloud. I mean, the early cloud, we had to get on board and actually manage all that. We shouldn't have to. It's the cloud somewhere. Shouldn't it just take care of it for us? So it's like, I mean, it's sort of like serverless was this newer technology post the advent of the cloud, but it seems like the cloud's not really here until we have serverless.
I think we're going through kind of this next phase of innovation within the cloud, James. Honestly, I think, you know, go back 10 or 12 years ago. You know, it was kind of like we're all talking about cloud, but who was really doing it? You know, I remember you would walk by a room in some office and there were still servers in there. Remember that, right? Like,
right.
And that's gone. That's gone. Like, and you know, that phase is over. Now it's like, okay, right, let's get things up and running and let's move our business to the cloud. And I think this third phase that we're entering into now is, how do we optimize this infrastructure?
Mhm.
And then when I think about it, it is truly infrastructure. And I think the concept of serverless is interesting to me. I really start to think about it as infrastructureless. I don't want to think about that stuff. I just want to be able to do. And I think we're headed in that direction. And 10 months ago, I was not a believer in this stuff.
Hmm.
Today, I'm a believer, and I really see that I feel strongly that this is where things are headed. In the next, is it 2 years? Is it 3? Is it 5? Is it 10? Man, I don't have a crystal ball, but
Mhm. Mhm.
I think we're headed in this direction.
Let's talk about Cockroach Labs and how it's addressing the database needs of its
Hmm.
clients. What's the Cockroach advantage? I do, as someone who covers the tech space, I do sense there's this little buzz around Cockroach, like, ooh, this cool company that's doing something cool. So explain to me why I'm getting that buzz. Like, what is interesting about Cockroach?
Yeah, James, I first got introduced to Cockroach DB and Cockroach Labs about it was about 5 or 6 years ago, and I met Spencer, our CEO, and I got to tell you, like from that day on, I haven't I it was something I couldn't unsee. It
Hmm.
really was. And it's basically saying like, look at, we've had databases for 30, 40 years now. Like we've had these relational databases. They they drive our lives, our healthcare, our phones, our banks, the nuclear codes. They're run on these relational databases. It is basically how businesses run. But all that stuff was 30 or 40 years ago, and it was built for infrastructure that was one way. With the advent of cloud and with the way things are moving towards distributed systems and ubiquitous compute, this legacy architecture doesn't work. And so really Cockroach Labs was created to reimagine and re-architect the database from the ground up. Let's not lift and shift and just run it in the cloud. Let's not like move it and improve it. Let's actually just re-architect and rebuild so that it is cloud native and it can take advantage of all the promise of the cloud. It can deliver on the scale that the cloud kind of gives to us. I was talking about geographic scale. How do you have a transaction happen in New York and Sydney at the same time and mitigate that in one single logical database? Man, that's a really, really difficult problem. But most importantly, and it just comes back to, we were talking about serverless, how do we make this really, really super efficient? How do I get the efficiencies of the cloud? How do I automate scale? How do I automate resilience? Like these mundane tasks that A, we don't want to do, and B, I got to tell you, it's hard to hire people these days. So like it's even hard to hire people to even manage all these things. So like
Mhm.
let's rethink the database so that it is still going to be the same type of relational database, but let's automate these mundane things and truly promise scale for organizations. And that's what we're doing here.
Hmm. Interesting. So let me ask another question that I'm sort of feeling my way on this one. This would reside any number of places. It might reside obviously in the cloud, as you're talking about. How would it interface with, say, Snowflake, which is known as a data warehouse platform? Would you have Snowflake and Cockroach Labs, or is it how does that system work?
Yeah, so absolutely. And look at the data market. If you think about the data market, there's been two big pieces of it. The OLTP, which is like transactional operational data,
Mhm.
and then there's OLAP, analytics and kind of the business analytics side. Snowflake is clearly in the OLAP kind of analytics side of things because the queries that you're asking of the data are different. Like there's a reason why there was a Teradata and Netezza and stuff, and then there was like an Oracle and a Sybase and DB2, and there was a reason because you're doing two different fundamental things.
Hmm.
We live squarely on the transactional operational side of things. Like what's the data that makes that business run? Whereas Snowflake is more on the analytics. Let's try to figure out things that are going on in our business.
Mhm. Mhm.
And I think and what they've done is just it's tremendous. Like the push towards really what a cloud service needs to be on that side is really interesting. We're doing something very, very similar to what they've done,
Mhm.
but on the transactional operational side of the house for data.
Hmm. There's a market for that. Let's look at the future of the database market. Say we instantly get in a time travel machine. We go into the year 2026. I mean, what will the database market look like then, or thereabouts? Or what are some key milestones we better get ready for now? Is my real question.
Yeah. So it's so funny, James. I had to actually look at my calendar because I don't even know what year it is anymore. This past 2 years has really messed up my calendar,
I'm
right?
not
Like,
sure either. Sometimes, yeah, I've got to look at my
I'm like,
iPhone. Right.
is it 21, 22, right? Thank God I
Sure.
have a phone to tell me. If I fast forward really like 3.5, 4 years from now, you know, I think that's an early kind of moment in time. I think of, 10 years from now, that's my life that I try to
Sure.
live in, because,
Yeah.
like especially here at this company, at Cockroach Labs, we aren't building a database of the past. Like we aren't building even a database today. We're building a database of 3 years, 5, 10 years from now, because I really do believe that the what we've had in our past has to change.
Hmm.
And I think, 3 years from now, we're going to see more and more organizations start to kind of move off of this legacy approach, this stovepipe approach of a database, and move into something that's much more distributed and much more cloud native,
Hmm.
as organizations really start to understand truly what scale means. And I think, scale in the cloud and this kind of advent of distributed systems really means one big thing for organizations. In the past, we used to think about logic, like the logical model of our data and where it lives, and or how it works with each other, the relationships.
Mhm.
I think in the future, we have to really think about the physical nature of our data. What is
Hmm.
the physical model of my data? Where does it live? Because A, I want to survive the failure of something, or B, I needed to have low latency access to whoever is accessing it. And then I think the regulatory and compliance laws that are, that mesh of regulation across our world,
Mhm.
that's going to get even more complex. And I think, I think the database has a role in solving those problems.
Well, it's interesting you talk about the idea of the physical nature of the data. I hear a lot about data being virtualized, so it almost doesn't matter where it is. I mean, how do those two ideas square?
Data, it absolutely matters where it lives. Again, I'll come, the speed of light is no joke, James. You can't beat it. Like I would love to be here
Mhm.
in how many years away it is that we figure out how to beat the speed of light. Because
Right, right.
man, as humans, it'd be really great. We can't. And
Mm,
so, it still takes X amount of time for an electron to flow over space. And
mm,
so delivering data to somebody in low latency and humans can discern real time, and it's usually about 100 milliseconds of time.
mm,
As humans is where it's the 100 millisecond rule, as we talk about that. And
mhm.
over that, you're gonna feel some sort of delay. Like fighter pilots, like in fighter jets, they think about this a lot. And
Right.
what is 100 milliseconds? How much space is that? Well, it's not the globe, dude. So that's actually a really important thing. And the physical nature of data is also important, because things fail, and if all your data is in one data center, I you no longer have access to it, or it's gone. Actually understanding these things is actually pretty important.
Hmm. Jim, I think you said it. Fascinating stuff. I thank you so much for sharing your insight today.
Yeah, happy to do it. Thanks for having me, James.